Welcome to a short demonstration of a new capability in EnSight 10.2 for reading in parallel OpenFOAM datasets into a parallel session of EnSight without having to merge the data at any point. So my starting point for this is a parallel OpenFOAM run. We've simply run OpenFOAM in parallel, in this case for 6 processors, and that's where I've stopped. I have not merged the data back. I have not run a reconstructPar. The data still is all in these separate pieces. So if I go into processor 0, you'll see all the time steps that are there and the standard information within the processor directory. Now, this capability is going to allow us to load the parallel OpenFOAM dataset into a parallel EnSight Server of servers capability without having to ever merge the data into one large chunk. So the first thing we want to do is run foam to EnSight and provide the case flag and give it processor 0. What this has done, it hasn't changed my main directory, but it has written in processor 0 an EnSight directory. Within this EnSight directory is basically the converted information in EnSight format for just this processor. And that can be quite helpful. So we've maintained the partitioning that we had in OpenFOAM. So all we really need to do is we're going to run that same operation, foam to EnSight minus case, and give it the other processors. Okay, you can automate this process through a shell script or a Python script or so forth. So 4 and 5. So we should find that in each of our processor directories, so if we go into processor 3, we have an EnSight folder or EnSight directory, and within there we have the specific files. Okay, now we can load up each of the processors separately, but we really want to open up all those partition domains into a single session of EnSight and keep it parallel. Okay, so the capability up to this point has existed in multiple versions of OpenFOAM. There's nothing terribly new about this capability so far. So what I'm going to do is I'm going to move from my whole directory here. I've got 3 files here, and these are 3 options for reading in this data set. So option 1 is a single case. So option 1 is really if you want to load into a single EnSight server session, and this is probably more academic than it is, because if you're loading into a single session of EnSight, you might as well just have run the reconstructPar and put the data set, just converted the single data set. So if I look at option 1, what this is basically a standard case file that is pointing from this location to the location where the different files exist, the mesh directory, the new T, the K, all the variables. At the bottom, we've used this appended case files and specified the total number of additional files that we have is 5, and that this is the directory for each one of those case files. Now, this works only for if you're reading into a single session of EnSight. So probably this is academic. So I won't really go through this further, but it is an option you could use. Option 2 is equal number of EnSight servers for equal number of OpenFOAM processors. So in this case, we have 6 processors that we ran in OpenFOAM, and I want to load them up into 6 EnSight servers. So if I open up option 2 here, we basically tell it that there are 6 servers going to be run, and each of the servers has a directory path and case file that's unique to him or her. Now, this would work well if our machine IDs are separated out and maybe not all on this machine or not all local here. And the number of servers run in OpenFOAM is equal to the number of servers run in EnSight. So for each of the processing data sets, we have an EnSight session, or an EnSight server, sorry. So that option may be not quite as useful, but may be useful if you wanted to do that. The third one, which I think is going to be the most useful one, is option 3 here. So this tells EnSight we have a collection of multiple case files here at the top, and this is the directory and the location for those case files. And then we have some other number of servers. So in this case, we have 3 servers. In this case, we'll be dealing out 2 of the OpenFOAM Parallel datasets, partitions, to each of the EnSight servers. Okay, so this number here could really be anything less than the number of OpenFOAM servers run. So I think this would be the most useful utilization of this type of file for instructing EnSight on how to read this dataset. So we've converted our data in each of the processors separately. That's step 1. Step number 2 is to create one of these 3 types of files. I believe this option 3 will probably be the most useful because it allows for a fewer number of servers than number of OpenFOAM datasets. And then we just simply will start EnSight minus HPC and minus SOS. Now, what we'll see when we load the dataset into EnSight, we'll show you how this will look. We'll use option 3 and we'll specify that we're going to be using the EnSight SoS reader here. Okay, so we've read our dataset in. We've got 51 time steps. We have our standard parts, but we also have these processor boundary parts in here as well. So let me turn off the top here and show you what these processor boundaries look like. These are the processor to processor boundary. There are parts which have been illustrating the processor to processor boundary location. So we can probably most likely turn the visualization of those entities off. Now we'll see that we have what are the fluid domain broken up into the different segments. And again, remember that these are pre-partitioned, so you'll see the partition information in here as well. But again, that shouldn't really bother too much. We should be able to turn the visualization of that part off. We could create a clip plane through here. Let's create a clip plane in X. And we'll create a clip plane here in Z. I'm going to go back and select my fluid domain in Z, create. So we have 2 different clip planes here. We can drag and see that this clip plane is through the whole domain, and this clip plane is also through the whole domain as well. Now, to illustrate the number of servers that we have, let's go back to internal mesh. Let's go back to our calculator and look for server number and compute a server number here. Now we'll go back through and color this clip plane here and perhaps that clip plane there. So you can see the different server numbers. We have 3 different servers that are loading up the data, and we've essentially allocated 2 of the OpenFOAM processor partitions to each of the EnSight servers. Coloring and looking at things, for example, if I were to take and color here by velocity, we should see this is now a nice continuous velocity field that we could utilize just as we were loading a standard data set, a single server data set. So using the capability within OpenFOAM to convert each processor into its own EnSight case, along with using this new capability of the SOS, it's not really a new capability of this particular file, but utilizing this particular capability of the file to specify the different case files to read into the single session of EnSight. The new capability in EnSight really is to allow a global parts list, as each of the different partitions have their own part list for their own parts in there. And so the new capability in EnSight 10.2 is to combine those local part lists into one large merged global part list that's not duplicated, so that in EnSight we see one session here, and we see one set of parts and one coherent set of parts within the session of EnSight. So that's a quick tour through the new capability in EnSight 10.2 for reading in parallel OpenFOAM datasets into parallel EnSight without having to ever merge the data. If you have more questions, please feel free to contact your local CI support or the main office at support@ensight.com.